Well, hello and welcome again to this Enlit interview series. Today, we have a very interesting topic, and that is the waste to energy sector. And to talk to me about that, I'm delighted that we have the president of ESWET, that's the European Suppliers of Waste to Energy Technology, Dr. Siegfried Scholz. So Siegfried, a very warm welcome.
Yeah, thanks for having me.
Great. Well, let's start with the basics. I mean, can you tell us what a typical waste to energy plant is, first of all, designed to do?
Well, it's designed, of course, to treat non-recyclable waste. That is the main target of an energy from waste plant. And of course, as a byproduct, it's generating power and heat.
Okay. And so just to give us an idea, what are the main sort of component elements that would make up a typical plant? What technologies are used?
Well, typically, the plant would start with a treatment plant, a sorting plant, a mechanical and biological treatment plant, and that is an integral part in most of the energy from waste plants. It's not as some think an alternative or a competition to the energy from waste plant, because of course we want to treat the waste, pre-treat the waste before it is then used in the energy from waste plant to generate electricity and heat. It then consists of a fuel hall and a bunker, of course of a boiler plant generating the steam, which then goes to the flue gas treatment plant and to the turbine to generate the electricity. And then, of course, depending on whether the electricity is produced, it's going to a turbine or it's going to a heat off-taker. And in most cases, it's going to both because you need to have an alternative if the heat off-taker does not need the heat. And then, of course, electricity can be provided as an alternative to the heat.
So in many cases, it's similar to what we would recognize as a conventional power plant, but with the fuel treatment element added on.
That is correct, yes.
Yeah. Are there any particular challenges about combusting the variety of materials that would be used that puts particular pressure or strain on the process?
Yes, it is something the plant needs to be designed for. The range of the fuels, both in terms of sizes as well as on heating value, and of course of chemical components.
Okay, well, I think we've got a good picture of what those plants look like. I mean, can you give us a sort of overview of where these are to be found in Europe? I mean, how widespread are waste to energy plants?
They are widespread throughout Europe, of course, more so in Northern Europe, in Germany, Scandinavia, and in France and Benelux than in parts of Eastern Europe and the South, where this is still to be introduced on large scale.
Okay, so can you give us an idea where waste to energy fits into the energy transition and the sort of drive to create a circular economy?
It is, of course, an essential part of the waste hierarchy. And I can only re-emphasize that it is treating non-recyclable waste. Waste generation in general is still on the rise in the world, other than most or some people think, and is also on the rise in Europe. The provisions are that there is a 60% worldwide increase by 2050. Source is the World Bank, so somewhat trustable source. That's why sustainable waste management is so important. And not all the waste we generate today is avoidable, reusable, or recyclable. There are only two essential alternatives for residual waste, and these are landfills or waste to energy technologies of some kind. What do we call residual or non-recyclable wastes? These are polluted, degraded when it's recycled too many times, and unrecyclable waste. And today in Europe, this waste still accounts for 52% of the total municipal solid waste generated. In 2018, the European citizens generated around 220 million tons of municipal waste, which is roughly half a ton per citizen. And half of this number, meaning 116 million tons, was made of non-recyclable waste. And thirdly, countries with higher rates of recycling have also higher waste to energy rates. That's also a common myth that when waste to energy plants are installed, somehow the beast has to be fed, and that by that the recycling rates are reduced. The opposite is the case, as statistics can clearly show. And of course, the waste to energy plants replace dumps and landfills, and the diversion of waste from landfills prevents the production of methane emissions, which is up to 84 times more potent than CO2 as a greenhouse gas over a 20-year period.
So I think what you're saying is we're not competing with recycling. This is almost a complementary process to that of recycling.
That is exactly right. Yes.
Yeah, yeah. And what about the question of whether it's a renewable process? That's a tricky one. What's the answer to that?
Well, it is renewable process in regards to its biogenic components, because between 50 and 60% of the non-recyclable waste are of biogenic origin, and they are thus renewable. And of course, the other remainder of the waste is of fossil origin and cannot be seen as renewable.
Okay. I mean, there are some critics of waste to energy saying that it's a very sort of carbon intensive process, damaging to air quality. How do you counter those kind of claims?
Both claims lack substance in state-of-the-art waste-to-energy plants. In 2019, for instance, a review of human health impacts close to waste-to-energy plants, and I need to read this out to you, found no studies indicating that modern technology waste incineration plants, which comply with the legislation on emissions, are a cancer risk factor. Also in 2019, a major study led by a team at the Imperial College in London and funded by Public Health England and the Scottish Government found no conclusive links to health effects from waste incinerators. And as already mentioned, between 50 and 60% of the waste are biogenic and thus neutral. And for the remaining fuels, alternative treatments emit far more CO2, not talking about plastic in oceans or sent to Southeast Asia or going to landfill. And of course, we are replacing fossil fuels in reliable power.
Okay, and presumably there's some sort of residual waste. What happens to that?
Basically, our plants are shrinking, are condensing, so to say, the amount of waste to a fraction of its original volume. Basically, it's 10%, around 10% of the initial volume, and that, of course, still has to be made use of. So one way is to recycle the metals and valuable components from that waste in treatment plants. But it cannot be denied that there is a certain remainder which will have still to be disposed of in protected and industrial facilities. But it is only a fraction of the initial volume and weight.
Okay. Well, let's look on the other side of things. What do you see as the potential for waste to energy growth in Europe? What do you think the long-term future is for the technology?
There's still a lot of demand. As I already said, there is a large portion of the waste which is still not treated, which is dumped or landfilled. So certainly in Eastern Europe and Southern Europe, also in the UK, there is a large market for waste to energy plants and more elaborated waste management as a system in those countries. Of course, there are also upgrades which are still to happen in the existing plants in Germany, in Benelux, in Northern Europe, wherever the market with the capacity was thought to be saturated.
And what sort of developments are there on the horizon in terms of technology or in terms of tying in with, I don't know, CCS, for example?
Yes, that is one of our focus developments because if we want to make use of the potential to reduce CO2 and even to become CO2 negative, that's the way to go. So CCS as such is not such a technical challenge. It's more a challenge of acceptance because the CO2 will be sequestrated in an industrial process, which is possible and state of the art. But where do you go with the CO2? It can be stored in caverns, it can be transported by trucks to these caverns, or it can be piped to the caverns. But personally, I believe the future is CCU, where the CO2 is transformed into usable fuels again. And these fuels could be ammonia, methane, or methanol, or something we can't even now think of. And the first plants of this kind are being considered and planned. And it's essential, of course, that the financial incentives are set in a way that these plants, which are expensive, really have a chance to be installed. Then, of course, we need to develop a more tolerant plant in regards to fuel composition, because there is one thing clear: waste composition will change in the future in basically all the countries we are observing, and that means the plants need to be able to be to run on fuels of different compositions, basically potentially lower heating values and also different chemical compositions than known today. And of course, we need to develop and install plants for treatment of bottom ash to recover materials.
Okay, so it sounds like there's a lot of interesting developments ahead, synergies with the world of green gases as well as recycling. You've joined, or you're leading ESWET at an interesting time. And what do you see as the mission for the association? What are you trying to achieve?
Well, the main mission for us really is to convince the public that we are part of the solution to achieve the Green Deal. And certainly, I'm convinced this is the case as long as waste volumes are still at present level or even increasing.
Well, you've certainly given Enlit Europe viewers a good picture of waste to energy. Is there one final message you'd like viewers to take away from our conversation this morning?
Well, it would be simply that message: we are the good guys.
Siegfried Scholz, President of ESWET, thanks so much for your time and talking to Enlit Europe today.
Thank you very much, and all the best for your conference.